mixing up another area afterwards. My mistake. Oh, sorry. I shouldn't be doing this. That is very bad on my behalf. Sorry. Yeah. Absolutely. So that one matter doesn't interest you. But yes, let's discuss. The more excavation and civil engineering related aspect. Who wants to answer and give Nadia an overview of what we had proposed? Lars, as you wish.
The guiding curves. That concept. That concept was sort of. It's actually two things that we want to cover for tunnels. It's first of all the sweep operations. That for that we take section solid horizontal, and then there's this alternative, string line sort of approach, which is guiding curves. And since software vendors weren't quite ready to have a completely curvature continuous representation of sweeps, and of course also alignment by itself is not curvature continuous in 3D, it made no sense to put all of this into one entity. So what we went for is have a geometric set as well as a section solid horizontal, where the geometric set is a set of curves, a set of polylines, I think, and they are pretty much what's connecting, or I think it's actually index poly curves, we said in the end, or both. But does anyone?
I was wondering if
No, we didn't set it.
Yeah.
We didn't. We just have a geometric curve set that can be then used to provide the let's say either string lines in terms of polylines or index poly curves, or offset curve by distances even. So that's probably why we didn't restrict this to describe the outer hull of connected points. That was sort of the rationale behind it, and that means that if you use section solid horizontal and you want a guiding curves geometry, then you would pretty much have one representation which is a section solid and another representation which is a geometric curve set, but both have to sort of be in line, so that the points are on the actual section solid. I see that this was not the best explanation. Let me share my screen. Maybe.
So
maybe you should like share the you going through the documentation, please. Yes.
I thought that somehow they interact, but not really. So you mean that these are two representations, right?
Yes, correct.
The guided curves are one representation, which could be also standalone, but which could in itself represent the geometry, but there is some like how to say correspondence between these two, between the section solid and the curves, guide curves. Somehow
we don't have a requirement for that. Yeah, exactly. Because we don't actually have a project requirement that would tell us I want to use polylines for guiding my excavation or something. I want explicit points for guiding my excavation. That kind of a requirement we don't know. It's really dependent on the exchange. It's not like it's every time the same, because for obviously a geometric curve set cannot be used for clash detection, right? So if the use case is clash detection, then section solid horizontal makes a lot more sense to be required. But if the guidance of a machine is required, and these explicit, Cartesian points have to be in the data set, then that has to be required. So whenever we are dealing with these 3D extruded geometries, it all depends on the project. It's just two different requirements for different use cases and different software exporting, importing the data sets. But both are, of course, in the requirements analysis. So the specification has to feature both of them. They are in the dataset, they are not connected. We think that's actually more of a project requirement in how far these two have to correspond to each other, what are the tolerances and stuff like that. That's not for us to decide because we don't even have that requirement, and it's probably different in different projects. But the requirement is that we need guided curves and that we need solids for exchanges, for different exchanges. So guided curve, like you see, it's a completely different identifier. Here it's a geometric curve set, and for section solid, it's an advanced web solid. So it's two completely separate shape representations. But of course, tolerances have to then be decided based on the requirements of the project.
And the guide curves are supposed to be, I think you said, polylines.
No, there's no restriction.
Okay.
We just have a geometric curve set. So it really depends again. So if you want, if the requirement is that there are explicit Cartesian points, then of course IFC polyline or IFC index poly curve makes sense. But let's say you want to have these guiding curves based on the alignment, so based on distance along, then the geometric curve set would be compiled from, instead of polylines, it will be compiled from offset curve by distances. And that means that you have distances along the alignment, explicit distances along the alignment, and an offset on the curve. Those would be probably three scenarios that we can think of right now. But we didn't want to set this in stone because obviously we don't know exactly what happens on projects and what the requirements there are. We could add the recommendation, of course, on the template if those three are plausible.
I made some slides. I think it was, I found them in an email from 27th of March. And I don't know, maybe someone with some artistic experience could take those slides and make something nice of them and actually add it to the documentation. I can just show what I
please
have.
show us the ugly version.
Oh yeah,
So,
exactly. We were using this from Andre, right?
Yeah, and exactly. So we have sort of, in the case where you have an equal number of sort of vertices in the profiles, you can use section solid horizontal, and if you want to describe sort of the path of these vertices between the profiles, you can have this geometric curve set, and this would be then one element with sort of both representations. And then we also discussed the case where you have profiles along the body where you have actually varying number of sort of vertices in the profiles. And in that case, we actually said that in the transitions, you would actually need something like a faceted B-rep sort of to represent the body, where sort of you have this maybe branching out of guiding curves then. So you would have a section solid horizontal here and a section solid horizontal here. Oh, sorry, maybe with with this geometric curve set, but then you would have to have sort of, for example, a faceted B-rep in between representing this sort of transition body.
And these are just scenarios for now. It's
Yeah.
not that
Yeah.
that
Yeah.
we would require this or encode this into the schema somehow. But the problem, of course, always is if you're using a section solid horizontal, you don't have a means of having more points in sequential profiles. You can't just add a point because it doesn't know what you wouldn't know what to do. But if you have the exact number of points always, then the path in between, of course, is a linear interpolation uh, uh, on the distance along. So you still get a curve, but it's not anymore curvature continuous. Pretty much, it's tangentially continuous, but curvature is a bit different. And we decided for that, like I said, very because the initial requirement actually was for curvature continuous, but I don't even know if the geometry course of most of the infrastructure software supports that, because mostly what we heard from 12D, from Quadri and so on, it's like, yeah, we have a set of profiles, but in between we use various methods to interpolate. It's not like it's a requirement that it's curvature continuous. And there's local methods that are used, and what was it? It was even not only local. It was certain interpolations were from companies themselves. So like I think had a method of doing it and so on, and that just doesn't work for the standard really.
So, so in order, for example, to import such a shape representation into my software, I still need to do it the old way. I need to import the section solid horizontal using its base curve and the profiles. I cannot combine, right, these two representations. Can I combine, for example, take the cross sections and somehow construct or reconstruct my solid by using these cross sections and the guide curves instead of the just wondering, instead of the one base curve that I have in the section solid?
It really depends on the exporter. If the exporter is precise enough, and the tolerances are precise enough, you could probably use both of them together. But we can't ensure that in IFC, how exact, for example, 12D would export the guide curves. This is mainly a matter of how the project that's dealing with this does it. I would prefer you treat them as separate entities, so separate representations, which you can then maybe show on one model, and based on the definition of section solid horizontal with a linear interpolation along the alignment, you can then visualize for the user how much the polyline where it doesn't match exactly with the section solid, but really using them combined, we can't ensure that I mean, we can start a new project where we actually define the alignment as a curvature continuous curve, and then we can also build upon that and derive sweeps that are curvature continuous. Then this, I think, we can make it happen. It's not a difficult definition. It's just difficult to implement because the calculations on the software side need to be quite complex. Not everyone is doing that or using that. So we don't want a standard that like 90% of software vendors cannot implement because their geometry core is not powerful enough. But probably this is a recommendation. So you know that because I know Nemetschek has quite a powerful core in NX. Nemetschek can do a lot of these things. It might be a business opportunity that you just visualize stuff like that in the software and show the users that if you don't use a 3D curvature continuous alignment, if you use a 2D curve plus a vertical profile, then you don't get exact results, and it depends on how far you want to take it.
So I will have to think it over, and I've been implementing the import of section solid horizontal of, I don't know, 1 or 2 months ago, but I forgot a little bit about how I did it and all the concepts related to this. So I'll have to think it over, and maybe I'll come back next time.
This
To
would be, I
discuss.
mean, if you do this would be a great showcase that we send it to 12D or Quadri or something like that, see what comes out, and maybe if you would do also the guiding curves, show where they grow apart. I mean, I would be very happy if someone does that, because section solid, we talked about this in the infra deployment already, even before, and nobody actually implemented it for a showcase.
We have actually in the Beaver control pull request, we actually have a small section solid horizontal that could be imported. It's still not merged, but it's there anyway.
Is it not just?
It's just a section solid horizontal. It does not have any guiding curves.
Yeah. Exactly. And I think if I remember correctly, it's just a line, not even an arc.
Yeah, maybe. Yeah, you talk about the alignment there.
Yes.
It might be. I don't remember now, but
yeah, me neither.
So
I think it was just a line.
Yeah, but you need to sort of walk before you can run and so on.
Yeah, obviously. I mean, exactly. You have a review of your pull request there also, Lars.
Yeah.
You also have a walking issue there.
But that's also a walk before run kind of case, right?
Exactly. That's a walking issue completely. So yeah, we do have some stuff that we can throw around and start doing that, but of course we need software vendors to do it, to actually produce more complex data sets. If we produce them programmatically, it's not certain that it's completely valid, because I also have a section solid example, but it's just a line in the end. That doesn't make much sense.
So I was implementing the import, right? The import of section solid horizontal somehow. Well, I don't know if it's correct because, because the concepts related to the gradient curve and all the segments, and I'm never sure if I understand them really correctly, but I can visualize this section solid horizontal in our software. It
Good.
looks okay, but I did also the export, but I don't use the gradient curve. Probably it was long ago. It was before the import. I don't use gradient curves at the moment, so perhaps it's not really what it should be exactly.
Do you want to provide us with those examples that we could check, at least from a syntax perspective?
The export.
Exports? Yeah.
Yes, maybe I could.
Okay.
And
Yeah.
What
But
you
I don't
just
have the alignment there. They have, you know, the curve is like part of the section, like self-contained, right? There is no alignments at the moment, and we are
that
struggling.
is exactly my issue, by the way. That we don't actually have examples where you would have a proper alignment with segments that are transition curves and so on. This is also my issue. Yes.
We are
actually
struggling currently in our team because I would like to implement all of this, and we are struggling with the management because they have other, you know, the product management, they have other priorities, and we are trying to get the approval to you know, to to do this implementation. But it's really a problem currently.
That's you know, the case by every single major software vendors. That's always there.
It's actually a pity. I think Ivar in the bever control case, he actually has an alignment there with transition curves and everything, but then the section solid actually uses just a line. I just checked, so that's a pity. Maybe we could just tweak it
Exactly.
a little bit and use the or maybe ask Ivar to use the alignment instead. But then, yeah,
this is exactly the problem. Just tweaking the data set is easy, right? Even having a curvature, continuous alignment, and the sweep upon it, a definition is super easy. You just put some stuff in there. We all know what the requirements are to get this geometry, but to actually have a data set that's going to be that can be visualized in different software and that everyone understands this properly. That's the issue, I think, and we don't have that. But you need some engagement of software vendors to you know fish out the problems of the definition. If there's a parameter missing somewhere, or if the description of a parameter is faulty and it can be understood ambiguously, we need to get that out of the documentation. Otherwise it's just going to be interpreted differently. And that's sort of what we have to do at some point. Just tweaking the data set won't help.
But from what I've understood, so Nadia, in a sense, with what she has done is leading the pack, and even if there is no alignment yet, the correctness of the code still can be checked, and
that of course we can do. Yes.
Yeah.
That's.
And maybe then pick up Ivar's alignments to for Nadia to reuse.
Of course, those are available.
Good.
Those are available for all the vendors.
Good. So are we sort of consolidating your confidence in what you have you've been doing, Nadia, so far?
Yes. Yes.
That's a small yes, but okay, that's a yes.
The problem is on my side. You are perfect. It's just that, yeah, as I said, I cannot go on implementing all the stuff, yeah, around this topic. So that's the problem.
It's the usual chicken and egg problem, right? The importers need files to test their imports, but the exporters wants to test their exports by importing it somewhere. So who's first? But
Completely correct. Yes.
Yeah.
That's what happens.
So we tested, we tested what we exported. So that's what we do at the moment. I export and I test by importing just.
That's of course a good strategy. But yes, of course, if you're the one that wrote the exporter and you're the one that wrote the importer, you're testing yourself, which again is we all know can be faulty.
Yes.
And just see if I'm not the only one mixing things up here. Sergey, you were referring to NX. To me, NX is a Siemens solution, isn't it?
Yeah. If I'm not mistaken, the geometry core of Siemens NX was procured by Nemetschek a couple of years ago and
really
used in Allplan.
I didn't know that. So, that's interesting.
NX,
you know this,
I don't know about NX, but we call it Parasolid. So I don't know if it's the same thing.
Parasolid is the name. Yeah. I just use NX because typically people know the tool, but yeah, Parasolid is the geometry core.
Ah, okay. Thanks for clarifying. Interesting.
Okay, thank you guys for clarifying. I will have to think it over and come back next time soon.
You're more
than talking welcome. About which, sorry a second, just one quick question to Nadia. You know, this series of technical support calls, in principle, we thought closing that one loop by the end of this year. So if we don't have that over Q1 and Q2, would that be for you a problem if you feel that your management is to sort of postpone a bit the possibility for you to implement? You would be then left on your own. Do you foresee this as a problem?
Well, I'm currently implementing still IFC 4.3, so I don't implement 4.4. That's also something really in the far future. I don't know when we will get to this. So first we are trying to somehow finish the main concepts of IFC 4.3.
And how far down the road are you percent-wise? Are you like 50%, 10%, 90%?
Well, the alignment is a crucial component, and we don't export it and we don't import it. So this is what we are struggling with currently. And I cannot say in percentage because for example, there is also IFC road, which is part of 4.3, right? And we have a road module in Allplan, but we do some exports, but just like tessellated geometries or BREPs, right? But I think for road, there are also some parametric types of geometries which are kind of aligned along the curve, right? I don't remember the names exactly of these types of geometries, but
section surface, yes.
Yeah,
you're correct.
So, and that's also something that we don't support yet, and so I struggled to do the section solid horizontal somehow, but yeah.
Sounds like you're not gonna run out of work soon.
Yes, depends.
So every concept that would be common to 4.3 and 4.4, of course, that matters to you short term. And then I think that maybe more excavation related or excavation support related. That is for you like a subsequent step.
We are not going to deal with it so soon. I mean, with the tunnel at the moment. So, and for IFC 4.3, there is this Beam for Bridges project, which we are currently trying to participate in. So there is, I think there is some kind of support for IFC 4.3 for the vendors.
Beam for Bridges. What is this? If I'm not aware.
IfcTunnel.
The
IfcTunnel. All right. Okay. Yeah. Okay.
So
Yes. Yeah, that's the most active part.
Yeah, it's actually the only project that deals with how to implement 4.3 because it's specifying an MVD, right? That's the actual problem, because first of all, the alignment-based reference view, so the base concepts is not locked down. So you can't even go and say I'm gonna implement 4.3 generically because you're missing that part. And this BIM for Bridges is actually the only project that deals with, okay, these kinds of concepts is what we want, and this is how we want them exchanged. It's the, let's say, non-abstract version of what we were doing for the last years. Finally, one project that deals with a concrete approach. This is how you do it.
Yep.
And that's important for software vendors, of course, because that's the only way you can then allocate resources and actually implement something. If it's not implementable, you're gonna have a tough time. And this is another aspect of the chicken and egg problem, right? So how do you actually get funds for something that's not implementable? So, and how do you implement something that doesn't have funds, right? So again,
yep,
it's really difficult. But these sort of projects, like the Ashto project, are really good for pushing the implementation.
Yep, and they take place in the US, which is
unfortunate indeed.
Which I mean, right? Yeah, of course, that has a significant impact on the software vendors, US-based software vendors. Good. Anything else we'd like to brief Nadia with that you think would be important?
Not now. Thank you very much for clarifying these concepts for me today.
And good on our part. Anything?
And I hope that we will meet again next time.
Yes, indeed. Please, anytime.
I can of course point you to the IFC files of the other software vendors on the tunnel deployment repository. We can do a selection of the ones that have a section solid and send you the links, probably.
Yeah, and likewise, feel free to send the export that you have already created so that we can double check the syntax.
Yes, please, please.
Yes. Okay,
Very useful for the other vendors. Yes, good point, Michelle.
So, Sergey, you would like to send me the links, or?
I can do the selection. Yes, I can do the selection. I can send you the links where they are. I have a meeting tomorrow with Lars where we will be talking about some stuff, and he also has the insight of maybe other examples that I don't have in mind. So you can get a selection of those tomorrow.
Yeah. Okay, great. Thank you very much.
Okay, lovely. Then thanks again for your time, and have a good day. We talk to each other again soon.
And thank you.
Take care.
Bye.
Cheers. Bye bye.
Bye bye.
Bye bye.
Have a great day, everyone.
Thank you.